Hi everyone, I'm Miss Pezza and welcome to Say It in Math. Have you ever been given a point on the graph of a function and wondered, how do I find its image after a transformation? Or perhaps you've memorized the transformation rules but aren't quite sure how to apply them to coordinates of a point. If that sounds familiar, you are in the right place. In this lesson, I'll show you a simple step-by-step method for determining the image of any point after compressions, expansions, reflections, and translations. By the end of this lesson, you'll understand how each transformation affects both the graph and the coordinates of individual points. We'll also develop a formula that we can use to solve transformation questions quickly, accurately, and with more confidence. So grab your notebook and let's get started. Now let's begin by recalling that when a parent function of the form y equals f of x undergoes multiple transformations, its equation can be written in general form as a f k x minus d plus c. As you can see, f of x is now interacting with coefficients a, k, d, and c. And each and every one of these coefficients will affect the graph of the function in a unique way. Every point on the parent function, x and y, is transformed according to the values of the coefficients a, k, d, and c. And the transformed coordinates are called the image coordinates, or simply the image points. Now, let's examine each transformation one at a time and together develop a formula that allows us to determine the image coordinates of any points quickly and confidently. So, we're going to get started with the coefficient a. When coefficient a is at work, the parent function y equals f of x is changing to become y equals a f of x. As you can see, coefficient a is multiplying f of x, which means that it's multiplying y. F of x and y mean the same thing, which means that for the same input of x values, the y values will be affected by a, and if a happens to be a number bigger than 1 or less than -1, then the function will undergo a vertical expansion. If the values of a are anywhere between -1 and 1, then the function will undergo a vertical compression. Now, what happens at the image point in the meantime? So the original point on the graph of the function x and y will now change, keeping x the same as it was in the original function, whereas the y value is multiplied by the coefficient a. So as an example, I'm going to bring in here a point on the original function as 1 and 5. If a is given to be, say, +3, then the image point now will change to become 1, and the y-coordinate will be multiplied by 3, so 3 times 5. So the image coordinates will be 1 and 15. Next, we'll look into coefficient k. So notice how coefficient k is multiplying the variable x, which means that the changes will happen in the x or horizontal direction. The function y equals f of x transformed into y equals f k of x will have the same y values, but it will require different x values depending on the value of k. So if the value of k happens to be anywhere between -1 and +1, for example, if the value of k is 1/2, we're going to need twice as large x values to input here to obtain the same values of y that we obtain in the parent function. And when you require larger values of x, it means that the function will expand horizontally. So we call this a horizontal expansion. Now, if the value of k happens to be either greater than 1 or less than -1, then For example, if you have a number 2 for value of k, then we're going to need fewer x values, lower x values, to reach the same y values as we did in the parent function, because whatever x value we input in here, the function will recognize it as, if k is 2, as twice times bigger, and it will produce a y value for an x that is twice times bigger. So that will cause the function to reach the y values that it did in the parent a lot faster, so for smaller values of x, and that will cause a horizontal compression. Now, the point with coordinate x and y in the parent function, this time will be transformed, and this is where we want to stop. First, the y value doesn't change, but if the k values, I'm going to start with k values greater than 1 because that's kind of easier to see. But if the k values happen to be, let's say, for example, 2, instead of, let's say, f of 1, now we're going to need 1/2 of it. So as you can see here, we're going to have to divide by coefficient k all the x values in the transform function, because the value of k is kind of helping and affecting the value of x, so the inputs of the x values. For example, if we happen to have a point with coordinates 6 and -4, and the value of k is equal to 3, then the new image coordinates will now be 6 divided by 3, and the y coordinate is not going to change, so it's going to stay -4. So in other words, in a more simplified form, the image coordinates will be 2 and -4. Now, what would have happened if the value of k is, for example, 1/2? So if the value of k is equal to 1/2, and I'm going to use the exact same point in here. Let's make some room. The same process needs to be followed. So if k equals 1/2, then the point 6 and -4 to produce the image will be divided by 1/2. Now, if you divide 6 by 1/2, you see that you have to multiply, so division changes to multiplication, and then you will have to flip the denominator. It becomes 12. So 12 and -4. So what that means is that if k is less than 1, you see that you're going to need larger values of x to achieve the same values of y in the function, in the transform function. Now, how many times larger? Well, you had 6. Now we're going to need a 12th. And the reason why is because the value of 1/2, which is the coefficient of x, will reduce any input of x values in here. So we will need to input a 12th in here in order to obtain the same values of y as we did in the original function. Now, the next transformation is the one caused by coefficient d. So in this case, we have y equals f of x transformed to become y equals f of x minus d. Now, when you translate or when you subtract a number from x, it means that you are moving the x values horizontally. X is a horizontal coordinate. And for this, recall again the parabola. So what does that mean? Well, if the value of d is positive, then the horizontal translation will happen in the positive direction, so to the right. If the value of d is negative, then there will be a horizontal translation to the left. So if you have a point in the parent function with coordinates x and y, and the value of d is positive, then this is going to move the x values, d units to the right. And we literally have to add in here the coefficient d. So the values of x will increase by d units, whereas the values of y will remain unchanged. Now, as an example, so I'm going to do an example here when d is positive or and negative. So say that the given point is 6 and negative 4. Now, if d happens to be a positive 5, then the image coordinates will be 6 plus 5, and the y value stays the same. We're not changing the y. So that means that the new coordinate or the image coordinates will be 11 and 4. So the only thing that we have changed in this case is the location of the point. So we have moved it to the right. So we haven't stretched it in any ways. So if d happens to be a negative number, for example, d equals negative 3, which will happen when we have the function f of x minus negative 3 or f of x plus 3, then the coordinates of the image points will be 6 plus negative 3, and the y value will stay the same, negative 4. So let's keep it the same here. So we have 6 plus negative 3, which is 3, and negative 4. Now, next we're looking into the last coefficient, or the coefficient c. So again, we have the parent function y equals f of x, now transformed to become f of x plus c. So we're adding a number to f of x, so we're adding a number to the y values. So we're going to say that if c happens to be positive, the y values will increase by c units. That will cause a vertical translation, c units up. And if c happens to be negative, that will cause a vertical translation of c units down. It's a pure translation because we are adding a number. So addition and subtraction assumes translations, multiplications are stretches, so expansions are compressions. Now, what happens to the coordinates of the point on the parent function xy? So the x coordinate will stay the same, but the y coordinate this time will move c units. And if c is positive, it's going to move up and c negative down. So let's take a look at an example. If we happen to have a point on the graph of a parent function, say 3 and 10, and the c value is equal to positive 4, then the new image coordinates will become 3. Nothing happens to x, but the value of y will be increased by 4. So the image coordinates will be at 3 and 14. If c happens to be a negative number, on the other hand, then we'll see that the coordinates of the point on the parent function, 3, 10, will keep the same x value, but then we're going to add the coordinate, the value of negative 4, so the value of c, to the y coordinate, and that will change the point on a parent function to 10 plus negative 4 to 3 and 6. So as you can see, the x stays the same, whereas the y values are shifting. Now, in general, then we're going to say that when a function undergoes multiple transformations, so I'm going to do a very simple modification here a little bit, so we can use the room here and organize everything accordingly. So we're going to say that in general, if we were to summarize all these changes in coordinates, if we were to summarize them into one final statement, we'll say that any point with coordinates x and y in the parent function will become, so remember, if x can be affected by the coefficient k, so remember that we divide by k. When that happens, division has to happen first. So first we're going to divide x by k, and then we'll be adding the coefficient d, which is the horizontal translation. Whereas the y values of the parent function will be multiplied by a, and then we'll add the translation, the vertical direction. So see, so, and this is the formula that we'll be using to determine the coordinates of any parent function when a function undergoes multiple transformations. So, and I put them together in here as well. Now, this is a formula worth remembering, but most importantly, we need to understand how it works and why it works the way it does. Now let's practice this formula on a couple of questions. So we have some parent function y equals g of x transformed into a function described by the following transformations. So this is a transformed equation. Now the point -5 and 4 is on the graph of g of x. So we need to find the coordinates of the image point. So in other words, we want to follow the story of this point, -5, -4, that was on function g of x, and see where it has been relocated after the transformations. So I will start off by writing the formula xy equals x over k, and then plus d, and then the y coordinate ay plus c. And we'll identify all the coefficients. So we have the coefficient a in our case equal to -3. We have coefficient k equal to 1. There is no coefficient in front of x. Now you see that here we have added a 4 to x, which means that we must have subtracted a negative, which will make the coefficient d -4. And lastly, we have coefficient c equal to -15. So true that the value of k is 1, so the function is not affected by it, but I am going to list the coefficient k regardless. So all you have to do now is substitution. So we're going to say that the point with coordinates -5, -4 now has changed to become, so -5 is now divided by 1 and you add -4. Whereas the y coordinate is now multiplied by -3. The y coordinate is -4. And then we add the coefficient c, which is -15. All we have to do at this point is simplify. So as you can see, we have -5 plus -4. That would make a -9. And here we have +12 minus 15 is -13. So when this point undergoes the transformations according to this function, and the image coordinates will be -9, -13. Now in the next part of the question, we will ask to find the coordinates of the image point or P prime after all transformations have been applied. Okay, so I think that we've already done this. So the idea is that we did this all together in one step. So I've been overthinking it, I guess, when I created the lesson. Now, in the next question, we have another point that has been transformed according to the transformations as described in part A. So what I'm going to do is I will rewrite that equation one more time. So we have y equals -3gx plus 4 minus 15. And we have the same point. We have the same point or not? No, it's a different point. So we just need this equation. So let's grab this equation. So we are working with the same function. And this time we're working with a different point. And what we know is the coordinates of the image point. So in other words, in this case, we do not know what x and y are. We don't know where point Q prime has come from. So we have about to discover. So we are given the image, we have to find the original point. So we're going to go ahead and substitute everything. So what we are given here is that the x is unknown. We know the value of k, which is 1, and the value of d, which is -4. So the value of y for the image would be equal to negative 3, which is the value of A, and then y that we don't know, and then plus the vertical translation, which is negative 15. Now, what we're given in this case are basically these coordinates, the image coordinates. So what that means is that if this is in more simplified form, if this is x minus 4, negative 3y minus 15, we will know that the exact values, or their numerical values, will be 11 and negative 17. So x minus 4 is 11, and negative 3y minus 15 is negative 17. So we'll have to solve each equation. And negative 3y minus 15 equals negative 17. Negative 3y equals negative 2. So y will be 2/3. So we're going to say that the coordinates will be 15 and 2/3. So this would be the coordinates on the given function. Now, this was the end of lesson 5. So that was made of 3 separate videos. And this is the practice section. And I encourage you to practice each and every question. So I'm just going to scroll very slowly so that you get an opportunity to stop the video and be able to look at all the questions and practice on your own. So there is 1, 2, 3 practice questions, and you have the answer key provided as well. And as always, thank you for learning with me, and bye for now.